We good?
Yeah.
Alright. Today's lesson is about density. Okay? So for today what we're going to do is we're going to talk about density. And we're going to talk about how, you've seen density kind of impacting your life and what have you. Okay? So, density. Well, the first thing we should talk about is we should talk about it mathematically. Okay? So, density has an equation, and it is this. Density is equivalent to the mass in grams divided by the volume. Now, we are going to express our volume in one of two ways. We are either going to say the volume is in milliliters, or we're going to say the volume is in centimeters cubed. So I know that I've asked you guys I always ask you guys to put, things in your thinking tube, right? Well, put this one there as well. And that is that 1 milliliter is the same thing as 1 centimeter cubed. Is that showing up where I'm writing?
Mm-hmm.
Okay.
Yeah.
1 milliliter, 1 centimeter cubed, they're equivalent things. I don't know if it's on your conversions sheet. It might be. Okay? But that's just something good to know. Volume is measurable in a number of ways, okay? There's something called volume displacement, where I take a beaker, right? I take an object, I put it in the object, and I have water in here. And what I do, guys, is I measure the before versus the after. You guys ever heard of Archimedes?
Yeah.
Right? The kind of off with your head, like the gold crowns, right? Well, this is called volume displacement. You measure what it was before, what it was after, you take the difference. The other thing I can do is I can take an object, right? And I'm not the greatest artist in the world, right? But we can measure its length. We can measure its width, and we can measure its, height, whatever you want to say. Whatever you want to measure it. But do you guys agree with me that volume is equal to length times width times height? I swear I've heard that somewhere before.
Mm-hmm.
And I think you guys have heard that. And that's where the centimeters cubed comes in. So this one would be centimeters cubed. This one would be volume in milliliters. Volume displacement. So, I have a way to remember density. Okay, guys, it's corny a little bit. I'm going to warn you now. Okay? But the best way for me to remember density is I remember that I have something called the density circle of friendship. And if I use the density of circle of friendship, it will be my friend. And by the way, this is my thing. Like, if you go to your college professor and be like, oh yeah, that's the density circle of friendship, he's going to look at you like you're crazy.
Mr. Gerbe.
Okay? It's like Mr. Gerbe's density circle of friendship. He's going to be like, sure, whatever. So, just FYI, this is kind of my thing. So you make a circle, right? Circle of friendship. You draw a line. Another one, and here's how you do it. We know that density is equal to mass divided by volume. Anytime something is over something, just like in our dimensional analysis problems, what operation were we doing? Division. And whenever things are next to each other, we say that we are multiplying. Well, that's the same thing here. This is the multiply line. This is the division line. And here's how it sets up. Density, mass, volume. And then all you do is cover up what you're looking for. So we all know density is equal to mass divided by volume, because I've told you, or you just knew it. If you cover up density here, what are you left with? Mass, division line, volume. Let's say you want to know the mass. Density times volume. So what do I refer to this as? The density circle of friendship.